Hello, everybody. Good afternoon. Good afternoon. Yes, we are live once again. Mm, We're back in this serious, yeah, the 3.25 uh, right of function maximum, the name of the function that returns the maximum element in a tree of int. Note that in Scala you can use x max y to compute the maximum of two integers x and y. Let's try writing a few more. Okay, this so until here, this is the problem. Maximum that returns the maximum element in. Let's see, 1 minute. Yeah, this and this is find the code. I did read the section for the before the just before reading the exercise. There is a section on algebraic data types, and they define and give you the code for tree and enumeration, which is new in Scala 3. This one, and I typed in the code, provided code. They also talk about, there is a little discussion on, you know, preferences between choosing to put some method inside here or over here, so you can call the function. They give you this function size as an example also, and you can call it in here as size and the parameter. And they also talk about extension methods and why these are needed. And if you want to go deeper in every Scala functionality feature, you can go to the Programming in Scala by Martin Odersky, another book. But the actual book, the Functional Programming in Scala, mentions a lot of the stuff too. And this is the alternative as a method style in the function method. Sorry, not me method too. To see if all of this will compile and define this tree after importing the tree enumeration and object enumeration. Define this tree branch left and call dummy, which return 2099. Yeah. Okay, now we need to solve the problem maximum. I also in this, after 2 weeks, I am bringing with me in this new being away for 2 weeks in this series, because if you follow the YouTube channel, there are other content being produced. So in this new comeback, I have this thing in which I can write in the. I forgot about this functionality of this laptop. So now I can draw over here, and this is an empty list. And when you were solving problems, we were solving problems in the linked list section. We have been using the empty list as a base case in the structural recursion patterns. And now we are dealing with trees. And can we define empty trees according to this code? It seems like we will only have leaf and a leaf with a value. So one case it will be like this. This is a leaf and this is the value. Okay, look like this leaf as the constructor and this the value. Value will refer to this visually. All right. Now I'm going to the next. Maybe this will make us spend more time in this problem solving, but you know, as long as you can get something from this, because if I will just solve the problem, then I can do it by myself without going live, or I already did it. Already did it 2 years ago until the middle of the book. And I don't remember why did I stop. But in this section, at this time, let us see if we can complete the entire book. Maximum, if, okay, maximum, where is it? Maximum, on a tree of type int, 10 minutes, 8 minutes of your time, sorry about that. Okay. Since it will have the same constraints that this first positive, we will add it as a extension method. You can do it also over here. Well, now let's do this. You can do it over here if the constraint isn't about int, the type of the tree. So I was flagging here. Where is the cursor? Okay, you can see we are starting at after 10 minutes of talking, but after being away for 2 weeks, I suppose that's a good thing. Okay, Deb, I'm starting to write maximum, which is the title of a song from Tetsuo Sakurai, last player. Maximum will return maximum. I am taking into account this code, right? So maximum is same as first positive. Don't take parameters, only the tree, which is called. And it returns an int, which is the maximum. Okay, int. The maximum int equals. Now we can, do some pattern matching. I'm not accepting this suggestion because of, remember what happened in the other videos about the tabs. Case list. And back to our chalkboard. What happened? Maybe I will abuse of this thing. What happens if you call maximum with a leaf, with a tree? Sorry, with a tree, but the tree happens to be only one leaf. What will happen is that, okay, you are giving me a leaf, and the maximum of this whole tree is the leaf, Hopefully that makes sense for you. Back to the code. And yeah, case list of value, I will give you the value. Now what happens? Back to our chalkboard, blackboard, whiteboard. Oh no, this is not a chalkboard. Okay, now you happen to give three. Okay, and these three have a branch. Sorry for the drawing. And this branch have another three. 9, 9, things like Q, and 5. What happens if you send this tree to the function extension method? What will you do? Because now it isn't a list. So you need to compare these two, right? Which one is greater than the other? And in this case is 9, and return the answer of, okay, you're giving me this, so I give you 9. 9 is the maximum of these two. Back to the code, branch. They are, I agree with them because you can get confused, but you know, L and lowercase l with the number 1. Left, right, and how can we compare the two of them? And then you remember and go back to the book, and they give you this x dot max y will compute the maximum of two integers x and y. So we will use this, you know, they are giving us this hint. We are doing just that over integers, right? So we need an